Hi guys, in the previous lesson we have created the estimator model dynamics coefficients or the A hat and B hat values. But in this lesson we will focus on the designing or obtaining the controller design. Okay? Controller design. What's the controller design in here? We have a specific reference values or the reference signal in here to drive the system in this point, okay? And so we should create let the error be to what the E equals to the what the x ref minus x. And so we need to obtain the derivative of this term, because we should minimize the whole terms in here, like this one, x ref dot minus x dot. And so we have the dynamics in here, and then we should put the equation or the x dot equation into these terms, okay? And so also we need to use the estimated A hat and B hat should be used or can be used in this form, because in this notation, because we only obtain these values. We don't know the physical parameters of the A and B, but we have in the microprocessor or in the algorithms A hat and B hat value, okay? And so E dot is equal to the what? The x ref dot minus A hat times x square. So should be plus in here, because the A hat has a negative term in here, and also minus B hat times U. This is important point to realize your estimator in here, and also controller design, because if we don't have the physical parameters of the A and B, and only we can utilize the A hat and B hat value in here. And so also we should define a Lyapunov function in here. Like L is equal to what? 1 divided by 2 times E square. Because we have the only objective is that to minimize the reference tracking error objective, okay? And so if we can combine the estimator model and these things, and so which we will call it to adaptive control, okay? And so if we're taking the derivative of this value or L dot value in here, like this one, E times E dot, okay? And also this should be equal to the what? The E times x ref dot minus or A hat times x square minus B hat times U, okay? And so in this objective we may utilize only the what? The U, or we can change the U values in here as a controller input, and then we can minimize the L dot value in here. Remember that the only condition is that L should be positive definite and L dot should be negative definite, okay? These are the basic controller term which is given in this notation, okay? And so also if we have this information in here and we have the E value, this should be equal to the what? The minus K times E square. These are my approach to what? To minimize whole system, or to select the proper values of the U or control action, okay? Because E square is always positive, and so if we take the K greater than equal to the 0, and so this function should over minimized in here, okay? And so we should delete these terms in here like this one, and then the k should be greater than 0 value. Okay, and so if we have this information in here, and so e is given in here, and these terms removes the square term in here, and then the final form is to what the minus k times e is equal to the what x dot ref plus a hat x square minus b hat times u. Okay, and so the b hat times u is equal to the what the x ref dot minus a hat x square plus k times e. Okay, and so in the final form u should be equal to the what the b hat times x ref dot plus a hat times x square plus k times e. This is the reference tracking control error function, or the u value, or the controller selection design. Okay, and so if we select the u values by using the a hat and b hat value in here, and then we may give the proper controller rule to the what to these notations. Okay, and so these are the controller design related to our nonlinear system. And then if we select the u value and set the proper values of the k in here, for example 10, 100 and 1 million, and so we can drive the system at any point in this notation. Okay, and so in the next lesson we will create a MATLAB Simulink model including the nonlinear system, physical system, and nonlinear estimators, and the controller action in here by using this u value. Okay.